Hello everyone, in this video I will be explaining the problem maximum level sum of a binary tree. Okay, so let's read out the problem. Given the root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes at that level x, is maximal. Okay, so we have given a binary tree wherein we have 170 and 7 minus 8 null. Okay, so let's take this example and understand. Okay, let's go to the board. Okay, so here on the board, someone had commented like my board was not visible, whatever I was writing was not visible, so that's why I have changed a bit. So we had 1707 minus 8 and then null and then null. What is it? It's a root. Okay, we have this as a root. In the question, what they said is, they said you have a tree. Okay, you have not tree, it's a binary tree because each children have either 0 child or one child or 2 child. So this is a tree, and level, this is the root of the tree, and its level is 1, and its children level is 2. Okay, its children level is 2. This its children level is next greater number, so 3, and here is 4. So now what they're asking is, you need to find whatever children we have, right? Node has some values. So let me call this as sum 1. The sum of the values of this level, and this is sum 2. This method h2. This has sum 3, and this level sum is sum 4. So you need to find smallest level whose sum is maximum, right? You need to find smallest level whose sum is maximal. So if there is only one level whose sum is maximum, so in that case that's the right answer. So this point is valid when you have multiple levels whose sums are equal and it is highest. So in that case we need to take the smallest one. Let's say your S2 is kind of 100 and your S4 is also 100. Sum of all the nodes at that level. So in that case, since S2 has got the lowest level, smallest level, so you need to print answer S2. I think you have understood. So let's draw a tree. We have roots. This is left children. This is right children. This is left children of 7. This is right children of 7. And null. So we don't have anything. And this was 0. So this is the binary tree that they given. Now let's don't go in a coding approach. Let's see first a normal thing. What is the sum of this level? This level is 1. This is second level. This is third level. Sum is 1. This sum is 7. 7 plus 0 is 7. And 7 minus 8 is minus 1. So among these three, which level has got a maximum sum? Obviously this has got a maximum sum. So in this case, you need to print to get the answer. Okay. Now let me check the second test case. Okay, second test case is kind of the same thing only. So we can go over explanation of this in this example, in this particular test case only. So what can we do? There are two methods. If there is a binary tree, so we need to go to all the levels. So in order to move to all the the nodes, you either have DFS or BFS. So you need to choose optimally which one is efficient. So in depth first search, what you are doing, you're basically going through the depth. Okay, it's like whenever path is asked, path or something like that, so you go for DFS. Whenever level is asked, okay, we are calculating level somewhere, it's a level, and DFS does the same thing, breadth first search. Okay, so it searches the first level, then second level, then third level. So I'll be writing a code using a BFS. You can do with DFS also. So in that case, you need to put some extra variable, like you need to, since you are moving, this is level 1, you need to make sure you maintain hash map saying one, its key is saying the level and its value saying the sum of that level. Okay, when you are moving to next, so it's like level 2. So in the here sum is 1, here sum is 7, and when you move again down, third level, sum is 7. When you are moving back, you will move to the right hand side. Now this is also third level, but your sum is going to be -1 now. Move back, move back, move. This is second level, so 0 is value, nothing is that 7. So it's like extra you will be requiring map and all, right? So we'll be doing DFS. Okay, I think you understood, right? That's how we did. Those who know how to do BFS, I think they'll find this very easy. Let me try to one more time. But don't worry, I'll tell you in this problem only how to do BFS also, so that you will understand, and future problem also you can solve. So first thing first, we need to maintain levels. So how do we maintain levels? Which data structure are we going to use? I'll be using a queue data structure. When I use a queue data structure, what will happen is we push the elements in the front. Okay, we push the elements in the front. Not front. We will be always pushing the elements into back, from back of the queue. Let's say this is a queue, and this is initially empty. You have put some value here, then you will put values on that. And when you want to pop it, it will pop from the front. It will push from the back, pop from the front. Okay, so I'll be using a queue data structure. So in the queue, first thing first, what I'll do is I'll insert my root. So let's say I've inserted root. When I inserted root, now I'll move to the next. When I move to the next level, in order to differentiate the next level, what I'll try to do is I'll try to put null pointer 1, and this null pointer will say me this is level 1 and this is null pointer. Whatever element you will be inserting, this is kind of a level 2. So first I'll insert root into my queue, and I'll insert null pointer, and I'll check if this root has left child, which means it has left child. If it does not have left child, so you don't need to move this way, right? Since it has, so let me write it as actually I'll be storing the tree data structure only, not the values. I'll be storing the whole node. Okay, this is the root node I'm storing. Now I'll store it as 7 node. Okay, and let me put it as 7 node. We have inserted. Now I'll check if root has the right child. It has the right child, so I'll put 0 node. Okay, I just put it. When I have pin, so again I'll move like basically I'm checking roots value, whatever is there front of the queue, because it always starts with the root value, right? So in front of the queue, whatever we have, so checking if this front is like root, so root's left child it has, so I'll just insert it. Root's right child we have, so I'll just insert it. Now I'll remove this root. Okay, when I'm removing this root, in the meanwhile, what I'm doing is, whenever I'm removing this, I'll add to my answer the value of the root, which is 1. Initially my sum is 0, I'll add 1. Okay, and now when I remove root, I will have to check if the next pointer is, if the next element in the queue is null pointer, which means that level is done. If that level is done, initially I will initialize my answer as, or you can say max sum as int minimum. Okay, So I'll check if int minimum is greater or 1 is greater, so I'll get answer is 1. You are understanding, right? So when it is null pointer, so it's like level is changed. That's why I'm making sure that my maximum value is like it is properly taken care. And actually we'll have to return the minimum level, right? The minimum level initially was nothing, so we have got sum as 1, which is maximum, so and it's level 1. Okay, so you can say minimum level is 1. Now null pointer we have got, so I'll remove when I got this null pointer, I'll remove this null pointer and I'll insert one more null pointer, which means, see, level 1 is done, it's all children are done. Okay, so when I move to level 2, so it's like all its children are we have taken into the queue, and once all the next level nodes are present in the queue, so next I'll put insert null pointer, which means whatever next element I am putting, that is kind of a level 3. Okay, so yeah, now again my sum I'll initialize it to 0. I'll take 7 node, I mean this is the front of the queue. I'll check this node if it has left side. If it has left side, I'll insert into my this 7 is different, this 7 is different. This one I'll call it as 1 and let me call it as 2. Okay, I'll insert this. Now I'll check if front of the queue right has children, it has children. That is -8 node. Okay, now I'll remove this element. When I'm removing this element, I'll add its value to my sum. What is value? Value is sum. Okay, now I've done that. Do I have next element, front of the queue as null? No, which means the level is not done yet. So I will check if this node 0 has left child, it is not have. So I'll not insert anything in there. If it has a right child, it does not have anything. So I'll not insert anything. Okay, so now I'll remove this. When I'm removing this, whatever value is there, I'll add to the answer. Plus 0, which is 8. So now next I'll check. It is a null pointer. If it is a null pointer, which means the level 2 is still null. Okay, so it's like one particular specific level is done. So now what I'll do is I'll check my sum, current sum with the maximum sum. So 8 is maximum, so I'll update my answer with 8. And the minimum level is 2 because this is the second level where we have got. Okay, so and then when it is a null pointer, I'll remove this and I'll add one more null pointer, which means the third level nodes we have taken care. As you can see, third level it has only 2 nodes, so we have only 2 nodes. Here also we are seeing like second level had 70 nodes and the null pointer was differentiating the next level. Now again my sum will be initialized to 0. I'll take front of the queue, which is 7. Okay, I'll add 7. I'll not add anything. First I'll check if does it have left child, it does not have. Does it have right child, it does not have. So I'll remove this. When I'm removing this, I'll add 7 to my answer. Nodes value, which is 7. Now remove, check if it is having null pointer or no. It has element, which means there are still nodes in the third level. So third level I'll check it is a left child, no. Does it have right child, no. So now I'll remove this. When I'm removing, I'll add its value. This is going to be -1. We have done that. Now I'll move to the next. It is like a null pointer. When we have a null pointer, which means the next level we are going. So when we are going the next level, what I'll do is I'll check first this sum. Sum is -1, but max sum is 8. So this is not a valid level. Okay, I'll remove this null pointer. Now when I remove this null pointer, my queue becomes empty. If my queue becomes empty, which means I'll say we have done all the travel and we have to go out answer which is the minimum. Okay, minimum level. Here if you see, when we were removing null pointers, we had 2 elements. Okay, so queue was not empty, which means we had to iterate through the level that is present. Here also when we removed these 2, we had null, but we had 2 elements. It was not empty. But here when we are removing null, so it is empty. When it is empty, we will have to just break. Okay. So I think the concept you have understood and the diagram. So the same thing I'll be coding. You just focus on right now coding, and you'll understand. And then what you can do is you can try around with 1 or 2 examples. So you'll get crystal clear with the approach. And then this is the way how we iterate through the BFS using BFS. Let me code in front of you. So I'll be telling everything. So first thing first, what we need to do is we need to take Q. I'll take Q whose data type will be node. Node I'll be storing. Why I'm storing node? Because when I am I'm taking the first, I'm in front of the queue, so it has to be node, because we need to check does it have left child or right child. If it has, then we need to insert into the queue. That's why. Okay, and I'll push root element. So it's a first level, and first level has just root, and then I'll put next null pointer. This will differentiate. We have just one element in the in the level 1 we have just one element, and whatever next element I'll be inserting into a queue, that will be differentiated with null pointer, and here it's like that way. And we have got a queue. Now I'll take minimum level, which is our answer. Okay, next I'll take maximum sum which is initialized to into minimum. Next I'll take level. I initialize with 0. I'll tell you why, because in the while condition I'll plus this plus increase by 1, so that we have a proper level. Okay, level I've taken. Now I'll check if not of queue dot empty, which means if you have some elements in the queue, it's like we need to iterate still through the tree. So first thing I'll take is I'll take sum as 0, like I'm calculating the level sum. Okay, sum is 0. Now again I'll take one value. I'll say while q dot not empty, q is not empty. If q is not empty, I'll check q dot front, which means whatever element is at the front of the queue, if it has a left child, okay, you can write not equals to null pointer also, or you can simply write this way. So if it returns non-null value, it means it has left child. So we can push this left child into the queue. So this will be inserted at the back of the queue, and since we had root and we have inserted null pointer, now left child will be inserted. So there is a differentiation. Root is a first level, and q front dot left, which means root's left child is at the level 2, so which is differentiated by null pointer. Now this is done. Same thing will do if q dot front of right. If root has in the example we are like first one we have inserted root, that's why I'm telling you root. Okay, but in the next iterations we'll be dealing with 7 0 as the front of the queue node. Okay, so yeah, if queue front has right child, so we need to insert front of right, so we have inserted the right child. And before popping the front of the queue, you take this you add the value of that node into your sum, okay, which will keep track of some of the all node values in the level. Okay, so once this is done, you need to pop. Once you popped it, so that if you find that next element, if q dot front equals to null pointer, if you have null pointer, which means the level is done. Okay, if the level 1 is done, it's like okay, so you need to now increase the level plus plus. Since I initialized with 0, I'm increasing the level, so it's like the first level is done now. Okay, now we need to check if your max sum is lesser than the current sum, the whatever sum it has previous values, I mean previous level value, if at the current level the sum is greater, which means this is highest value, right? So your max sum is going to be sum, and your minimum level, which is like answer, is going to be level. Okay, once you have done this, now which means the answers and all you have calculated, now you need to pop this null pointer. You pop this null pointer from the queue, which means the like this level is done. Now we'll have to deal with the next level, and one thing you'll have to check, if queue dot empty, okay, if queue is not empty, which means there are certain levels right now we'll have to deal with in the, like we have next level elements in the queue, so we'll have to deal with that also. So before dealing with that, we'll have to push again null pointer, as I said in the board, because this will differentiate next level node whatever you're taking, and then if it's the left and right children you're taking, that is going to be in the next level. Okay, and we should be differentiated by null pointer. Once you've done this, you'll have to break. Why I'm breaking? Because level 1 is done, so I'll have to break from this while loop, okay, so that your sum is initialized to 0, and then do the same thing. Once you come out of this, return your minimum level. So I think this looks good. Q we have root elements, we have initial null pointer differentiating, and this is our answer, this is max sum, levels, and we are increasing level. Everything looks good. Let's try to run it. Yeah, it is getting sample test is getting fast. Let's try to submit it. Yeah, it got accepted and beats 100% of the user. The reason it beats 100% is that we are using BFS. If we have used DFS, then we would have taken the extra space. So space complexity would be more. So let's start to analyze the time complexity. Space complexity, if you try to do at max, we'll be storing 2 power h elements in the queue, not more than that. Okay, so h is basically log of n, so it's like 2 power log of n elements will be storing into queue. So this is space complexity. And if you try to analyze the time complexity, so since there are n elements in the tree, we are going to all the nodes, right? So it's like O of n. Overall, the time complexity of these two loop is O of n. So yeah, thank you guys for watching the video.